Okay, so we're asked to turn this into vertex graphing form. What is vertex graphing form? Yep. Mhm. Minus p. Yep. Yep. Good. So, if I want to turn it into that, first off, I need to get rid of any coefficient that I have in front of my x squared term. So I got to get rid of that 2/3, right? So factor out the 2/3. And again, this is an expression, so I have to factor it out. I can't divide by this. So I factor out the 2/3, and I get x squared minus, and then I got to think, okay, the 4, if I'm factoring out 2/3, what's that going to turn into? So what you can think of really is the 2/3, what multiplies by 2/3 to give me 4, and easy way to find out is just think about this in terms of division, right? Because factoring really is kind of the same thing as division, you just are left with something up front. So 4 divided by 2/3 would be like 4 multiplied by 3 over 2, 2 and 4 reduced to 2 and 1, so 2 times 3, I'd get a 6. So that'd be 6x. And really, all I want is just to factor those first two terms. And I'm just going to leave the negative 18 in there, like outside the brackets here. So I'll just go minus 18 like that. Okay? Now, the reason we're trying to get that is we want this thing squared. So we want something squared like this. Now, in order to get there, I need to turn this part in the middle here, inside my brackets, I need to turn that into a perfect square. So the way I do it is I think, okay, well, what is going to, if I have stuff that's going to add to negative 6, what do I do in order to get the thing it's going to multiply to? Well, what I do is I take half of the middle term, half the linear term. So I go half of that negative 6, which is negative 3, and then I square that negative 3 to get 9. And what I do is I add that 9 in here, but the problem is that I can't just randomly add a 9, so I also have to subtract the 9, right? And so once you've done that, now I'm thinking, okay, great, I have the first 3 terms are a perfect square. Like I could easily factor that. It's a trinomial square, right? So I could factor that as x minus 3 all squared, but I still have this negative 9. So how am I going to get rid of that negative 9? Well, what I do to get it outside the brackets is I distribute the 2/3 into that negative 9, right? So 2/3 times negative 9. So I'm going to have the 2/3 and then x squared minus 6x plus 9. And then when I multiply 2/3 times negative 9, what do I get? Well, 9 divided by 3 would be 3 times 2. So yeah, negative 6 minus 18, right? And then when you look at the thing inside the brackets here, the x squared minus 6x plus 9, if you factor that, again, think trinomial square, or the easy way is just look back to here. So it's going to be, yeah, x minus 3 all squared. And then outside, I've got minus 24. Yeah. So if you think about this in terms of our vertex graphing form, your a value, right here, your 2/3, right? Your p value, so a would be like 2/3. What would my p value be? It'd be 3, right? Because it's x minus p, right? And then the q value, what would that be? Negative 24. So then you could start talking about what that actually means, right? So we could say, well, first off, does this thing open up or down, the parabola? It opens up, right? Because you've got an a value that's positive. So because it's positive 2/3, it's got to open up. And then you can also think about, okay, is this thing wider, narrower, or normal? Okay, and the way you know is normal would be 1. If it's less than 1, like this, 2/3, then what's going to happen is it's actually going to get wider. And then if it's bigger than 1, it'll get narrower. And then finally, the 3 in the q, or 3 in the negative 24, what does that tell me? That's going to be the vertex. So when you think about this function, what it's really going to do is have a spot at 3, negative 24, like down here somewhere, and it's going to open up. So it's going to be a vertex down here at 3, negative 24.